Welcome to our brief introduction lesson on something that I find very interesting called indirect measurement. So go ahead and make sure you have a piece of paper out. You can just write out indirect measurement. Okay, so what is this interesting concept of indirect measurement? You're going to want to write this definition down. Indirect measurement is basically using the properties of similar figures to find lengths that are difficult to measure directly. So in other words, there are things that we can do using nature, shadows and sunlight, that allow us to measure things even though we can't measure them directly. So in the picture on the left, we would be able to mathematically calculate the height of the pyramid, even though you can't obviously just crawl up the pyramid and measure it with a ruler. There are mathematical ways that occur because of the angle that the sun hits things and creates shadows that allow us to set up some proportions to figure out what that would be. The one thing that I want to point out is that it says indirect measurement uses the properties of similar figures. Okay, so we're talking about, in this case, obviously, you can see from the picture, we're talking about triangles. And specifically, we're talking about right triangles. This picture, the way that the sunlight hits the pyramid and bounces off a shadow, because this man is standing at a 90-degree angle and the sun is also to his back, he's standing and making the same angle and the same type of triangle as the pyramid is with his shadow. And so basically these are similar triangles that you can see, and you would be able to do, if you knew the height of the man and the length of his shadow, you would be able to do a type of calculation to figure out the height of the pyramid. Now let's look at a different example for now. We'll look at the flags right here. I want you to sketch those flags out. It can be a very brief sketch, but sketch out the flag and its shadow. And we're going to go ahead and take a look. If we saw the smaller flag, we see that it's creating a 2-foot shadow, and we are able to measure the 7-foot flag because 7 feet isn't really that tall. Basically, this is, even though we don't see a triangle with our eyes, this is creating, between the shadow and the flagpole, it's creating a right triangle that is similar to the right triangle right next to it, the flag right next to it. So because of the way the sun is hitting it, because of the shadow that it's created, they are similar triangles. We can set up a proportion just like we would with similar figures in order to solve for the height of the taller flagpole. So what we could do is the height of the flagpole compared to its shadow, which is 6 in this first example. And then in the second example, the shorter flagpole, we're going to say equal to, because we want them to be proportional. 7 is the height of the flagpole, and 2 is the length of its shadow. So now we can use our multiplication fish, cross multiply. 7 times 6 is 42, equals 2h. And then what you'll do is divide by 2 on both sides. 42 divided by 2 is 21, equals h. Now this makes a lot of sense that the height here would be 21 feet, because what we notice when we look closely is that this shadow is 3 times as large as the small flagpole, which means that the height should also be 3 times as tall. So 3 times 7 does make sense that it would be 21 feet. So that's just one example of how we can use similar figures to determine how tall something is that's difficult to measure, such as a taller flagpole. And this is a real skill concept that you can use in real life. You have to be careful of the way you use it, though, because the sunlight has to hit at a certain angle, and there are types of shadows that you can and can't use. But we'll talk more about that in class. Okay, similar triangles. We already do have this definition, but I do want you to write it down one more time. They're triangles that have the same shape but different sizes. Similar triangles are proportional. That means their sides have a particular relationship with each other, and the sides themselves also have a particular relationship. So if we are comparing the similar triangles ABC and DEF, what are some acceptable ways to compare ABC and DEF? What I want you to do is quickly sketch triangle ABC and triangle DEF. You don't need the colors, but just go ahead and sketch that. And now we're going to go ahead and look. The most obvious way, to me at least, for us to compare them would be the short side of A and the longer side of B. So we would say A over B is going to be equal to the short side of this one compared to the longer side. So D over E. Now that's just one way that you could compare these four side lengths. There are a couple of other ways as well. I can think of at least 4 ways right now. So go ahead and on your paper, press pause, and then on your paper, go ahead and see if you can think of at least 1 or 2 more ways that you could accurately compare triangle ABC to triangle DEF. Okay, let's go ahead. Oh, sorry. I think I accidentally deleted some of those. But we'll take a look at a couple of things that we could have done. We already said that we could compare AB to DE. Okay, and that's the one that we looked at in our example. But you could go backwards, or what we would consider backwards compared to what we just did. You could compare the long side, B, over the short side, A, and then set that up to the long side here, E, over the short side, D. Okay? Another thing that we could do, if we wanted to, is we could compare the short side of this triangle, okay, A, to the short side of this triangle, D. So A over D, and set it equal to the long side of that triangle, B, over the long side over here, E. Or we could flip that all around. We could do, B, or I'm sorry, D over A. And then since we started with the smaller of the triangles, we'd have to have E on top, E over B. So there's a lot of different ways that you can compare this. But just because there's a lot of ways doesn't mean that every single possible way works. Let me give you an example of something that would not be an acceptable proportional comparison. Let's say that we started here and we said A over B. Okay? So A over B. Sorry, it's taking me a while to change over my colors. I cannot say that that is equal to E over D. And the reason is that A should be matched up with D, and they're not matched up. They're across from each other. And in addition to that, obviously, B should be matched up with E, but they are also across from each other. So this is something that would not be an acceptable comparison. All right, so now that we've reviewed how to set up similar triangle comparisons, let's go ahead and apply what we know about indirect measurement to solve for mysterious height of a tree. It says, because both objects are standing at a right angle and the angle of the shadow is consistent, similar triangles are formed. Now, you might be wondering what I mean by the shadow is consistent. If you notice sometimes when you're outside and the sun is out, sometimes your shadow looks really, really big. Sometimes your shadow looks really, really small. It depends on the angle that you're standing towards the sun. And basically what we're showing here is that these two objects, the tree and the ruler, are standing at the same angle to the sun, and they're also standing at a right angle to the ground. So because of those two facts, it is creating right triangles and also similar figures. So when we take a closer look, we can set up a little proportion here. So H over 24 equals 4 over 6. You can actually go through and solve this proportion using the proportion fish, but there's actually a faster way if you were to notice that we're multiplying this bottom number times 4. So we're also going to be multiplying this top number by 4. So if you did it that way, you would know that h has to equal 16 feet. Or if you had done the multiplication fish, of course, you are allowed to do that as well, you would have 96 equals 6h. Sorry, 6h. And you would divide both sides by 6 and still get 16 as your answer, 16 feet. All right, that's it for now. Thank you for watching.